if we do the same thing for the vector W3, I could write down the equations and so forth, but what I'm saying is if you take this and simplify it, or simplify the expression with the specifics of V1, V2, and W3, do just what we did here, get it down to a matrix and reduce that matrix. At the end, you're going to end up with this matrix, or you could end up with this matrix. You don't necessarily end up with a 1 here, but you can, because if you had a 0, 0, 7, you could still divide this row by 7 to get 1. Of course, you can multiply this row by anything you want, so you could get any number here, but you're going to have 2 zeros here because of the way the coefficients in the first 2 rows work together to get rid of the coefficients down here. Okay. What does this mean? Well, this tells you that 0 equals 1. And there is no solution then. W3 is not in the span of the set V1, V2. You can check W2 out. Most people, when they work this problem, just did the thing by inspection, which is pretty good. Most people figured out how W3 is, I think, 2 times one of these plus 1 times the other, or maybe there's a minus in there. If I wrote them down, I don't remember what they were, but it was pretty obvious. But not so obvious I wasn't impressed that people could do it. However, being able to eyeball it and see how the letters are combined, that's great if you can do it. And it certainly doesn't hurt to try, but you don't want to spend much time on it because usually you're not going to eyeball it. I mean, usually you don't have integer coefficients. You know, C1 and C2 aren't integers. They might be square roots of weird numbers. They could be just about anything, and you're not likely to get that by eyeballing in a real situation. So in a real situation, your numbers are going to be a little more complicated, and you're going to just have to do this. Okay. Anyhow, that's how you determine if a vector is in a span of 2 other vectors.